Have you ever wondered about the astonishing secrets the universe holds? Are you curious about the incredible discoveries that have changed our understanding of space? From black holes to distant exoplanets, the cosmos is full of awe-inspiring phenomena waiting to be explored. Join us as we uncover 15 mind-blowing space discoveries you need to know. Join us as we delve into these amazing findings and see how they expand our knowledge of the universe. The first image of a black hole. In April 2019, the Event Horizon Telescope collaboration achieved a monumental milestone by capturing the first ever image of a black hole. This groundbreaking image revealed the supermassive black hole at the center of the galaxy M87, located about 55 million light-years from Earth. The image showcased a bright ring of light encircling a dark shadow, the event horizon, beyond which no light or matter can escape. This achievement was made possible by synchronizing 8 radio telescopes worldwide, creating an Earth-sized virtual telescope. This observation not only confirmed the existence of black holes, but also provided critical support for Einstein's theory of general relativity. The EHT's success marks the beginning of a new era in studying black holes, promising to reveal more about these mysterious cosmic giants. The discovery of gravitational waves. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made history by detecting gravitational waves for the first time. These ripples in space-time, predicted by Einstein's general theory of relativity, were caused by the collision of 2 black holes over 1 billion light-years away. This discovery opened a new window for observing the universe, allowing scientists to study cosmic events that were previously invisible. Gravitational waves have since been detected from multiple sources, including merging neutron stars. These observations have provided invaluable insights into the behavior of matter under extreme conditions and have confirmed the existence of binary black hole systems. The study of gravitational waves continues to revolutionize our understanding of the universe and its most violent events. The discovery of thousands of exoplanets. The search for exoplanets, planets outside our solar system, has been one of the most exciting areas of astronomy. The Kepler Space Telescope, launched in 2009, revolutionized this field by discovering thousands of exoplanet candidates. Among these, many are Earth-sized and reside in their star's habitable zone, where conditions might be right for liquid water to exist. Notable discoveries include Kepler 186f, an Earth-sized planet in the habitable zone of its star, and the TRAPPIST-1 system, which has 7 Earth-sized planets, 3 of which are in the habitable zone. These discoveries have profound implications for the search for extraterrestrial life and have expanded our understanding of the diversity of planetary systems in the galaxy. Hubble's Deep Field Images. The Hubble Space Telescope has captured some of the most iconic images of the universe, including the Hubble Deep Field and Hubble Ultra Deep Field. By focusing on a tiny, seemingly empty patch of sky for extended periods, Hubble revealed thousands of distant galaxies, some of which are among the oldest and most distant objects ever observed. These deep field images provide a glimpse into the universe's past, showing galaxies as they were billions of years ago. They have significantly advanced our understanding of galaxy formation and evolution, and have demonstrated the vastness and richness of the cosmos. The Hubble Deep Field images remain a testament to the power of space telescopes to explore the farthest reaches of the universe.
The Cassini-Huygens mission to Saturn.
The Cassini-Huygens mission, a collaboration between NASA, ESA, and ASI, provided an unprecedented view of Saturn and its moons. Launched in 1997, the Cassini spacecraft spent 13 years orbiting Saturn, sending back stunning images and valuable data. Among its most significant discoveries was the detection of active geysers on Enceladus, indicating a subsurface ocean that could potentially harbor life. The mission also revealed the complexity of Titan, Saturn's largest moon, with its lakes and rivers of liquid methane. Cassini's observations have transformed our understanding of the Saturnian system and highlighted the potential for life on its moons. The mission's legacy continues to influence planetary science and exploration.
Mars rover's discoveries.
Mars exploration has been significantly advanced by rovers such as Spirit, Opportunity, Curiosity, and Perseverance. These rovers have provided detailed analyses of Martian geology and climate, revealing evidence of ancient water activity and the potential for past life on Mars. Spirit and Opportunity, which landed in 2004, discovered signs of ancient riverbeds and minerals that form in the presence of water. Curiosity, which landed in 2012, found evidence of ancient lakes and organic molecules, suggesting that Mars could have supported microbial life in the past. Perseverance, which landed in 2021, is searching for signs of ancient life and collecting samples for future return to Earth. These rovers have revolutionized our understanding of Mars and paved the way for future human exploration. The discovery of dark energy. In 1998, astronomers made a groundbreaking discovery that the universe's expansion is accelerating, driven by a mysterious force known as dark energy. This discovery was based on observations of distant supernovae, which appeared dimmer than expected, indicating an increasing expansion rate. Dark energy is thought to make up about 68% of the universe's total energy content, yet its nature remains one of the biggest mysteries in cosmology. Understanding dark energy is crucial for determining the universe's fate. If the expansion continues to accelerate, it could lead to scenarios such as the Big Freeze, where galaxies drift apart and stars eventually burn out. The discovery of dark energy has profound implications for our understanding of the cosmos and the fundamental forces that govern its evolution.
The Kepler Space Telescope's exoplanet discoveries.
The Kepler Space Telescope has been instrumental in discovering thousands of exoplanets, greatly expanding our knowledge of planetary systems. By monitoring the brightness of over 150,000 stars, Kepler identified exoplanets through the transit method, detecting the slight dimming of a star as a planet passes in front of it. Among Kepler's most significant discoveries are Earth-sized and potentially habitable exoplanets. Kepler 186f, an Earth-sized planet in the habitable zone of its star, was a milestone in the search for Earth-like planets. Kepler's findings have shown that planets are common in the galaxy, and that many stars host multiple planets, suggesting that the conditions for life might be widespread.
The discovery of water on Mars.
The discovery of water on Mars has been a significant milestone in the exploration of the red planet. Evidence of water in various forms, including ice, vapor, and briny liquid, has been found, suggesting that Mars once had a more hospitable environment. The Mars Reconnaissance Orbiter detected hydrated salts in recurring slope lineae, indicating seasonal flows of briny water. Radar data from the Mars Express spacecraft revealed a subsurface lake beneath the southern polar ice cap. These discoveries have significant implications for the planet's potential to harbor life and for future human exploration. Water is a crucial resource for sustaining life and could be used for drinking, growing food, and producing fuel. Neutron star mergers. The observation of neutron star mergers has provided new insights into some of the most extreme events in astrophysics. In 2017, LIGO and Virgo detected gravitational waves from the merger of two neutron stars, followed by a gamma-ray burst and observations across the electromagnetic spectrum. This event, known as GW170817, marked the first multi-messenger observation, combining gravitational waves and light. The collision of neutron stars produces heavy elements like gold and platinum, helping scientists understand their origins. Observing these mergers has provided valuable information about the speed of gravitational waves, the properties of neutron stars, and the rate of neutron star mergers in the universe. Multi-messenger astronomy has become a powerful tool for studying the cosmos.
Fast radio bursts.
Fast radio bursts, or FRBs, are intense bursts of radio waves lasting only milliseconds but releasing enormous amounts of energy. Discovered in 2007, dozens of FRBs have since been detected, with some traced back to distant galaxies. The origins of FRBs remain largely unknown, but they are thought to originate from powerful astrophysical events. Repeating FRBs, such as FRB 121102, have provided additional clues, allowing astronomers to study these bursts in more detail. FRBs offer a unique opportunity to study the intergalactic medium and the large-scale structure of the universe. As radio waves travel through space, they interact with matter, providing information about the density and composition of the intergalactic medium.
New Horizons exploration of Pluto.
The New Horizons mission, launched by NASA in 2006, provided the first close-up images of Pluto and its moons. In 2015, New Horizons flew by Pluto, capturing detailed images and data that revealed a complex and diverse world. Among the most striking discoveries was the heart-shaped region called Tombao Regio, consisting of a vast, icy plain known as Sputnik Planitia. New Horizons also discovered active geology on Pluto, including nitrogen ice glaciers and towering ice mountains. The mission's findings extended beyond Pluto to its largest moon, Charon, which exhibited a varied landscape with deep canyons and a large equatorial ridge. The data from New Horizons has transformed our understanding of Pluto and the outer solar system. Oumuamua, the first interstellar visitor. In 2017, astronomers detected an unusual object passing through the solar system, later named Oumuamua. This was the first known interstellar object to enter our solar system, traveling on a trajectory that indicated it originated from outside our solar neighborhood. Oumuamua's characteristics were puzzling, including its elongated shape and non-gravitational acceleration. The discovery of Oumuamua provided a rare opportunity to study an object from another star system. Its origins and nature remain subjects of intense debate, with hypotheses ranging from a fragment of a larger body to an interstellar comet. Oumuamua confirmed that objects from other star systems can pass through our solar system, offering potential clues about the formation and evolution of planetary systems. The Cosmic Microwave Background, CMB. The Cosmic Microwave Background, CMB, is the afterglow of the Big Bang, providing a snapshot of the universe when it was just 380,000 years old. Observations of the CMB have been crucial for understanding the early universe, its composition, and its evolution. Missions like COBE, WMAP, and Planck have provided detailed measurements of the CMB, revealing its temperature fluctuations and polarization. These observations have confirmed key aspects of the Big Bang theory and provided precise measurements of the universe's age, composition, and geometry. The study of the CMB continues to be a vital tool for cosmology, helping scientists test theories of the universe's origin, evolution, and fundamental physics. Star formation insights from ALMA. The Atacama Large Millimeter Submillimeter Array, ALMA, in Chile has revolutionized our understanding of star formation and the early stages of planetary systems. By observing the universe in millimeter and submillimeter wavelengths, ALMA can peer through dust clouds that obscure visible light, providing detailed images of star-forming regions and protoplanetary disks. ALMA's observations have revealed intricate structures in protoplanetary disks, such as gaps and rings, indicating the presence of forming planets. It has also detected complex organic molecules in these disks, providing clues about the chemical processes that lead to the formation of life-bearing planets. ALMA's findings are helping to answer fundamental questions about the formation and evolution of planetary systems. These 15 mind-blowing space discoveries have expanded our understanding of the universe and opened up new frontiers in astronomy and astrophysics. From black holes to exoplanets and interstellar visitors, each discovery brings us closer to unraveling the mysteries of the cosmos. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Have you ever wondered what it would be like to travel through time? Imagine jumping forward to see the future, or going back to fix a mistake. What would that even look like? Time travel has fascinated humanity for generations, inspiring countless books, movies, and wild theories. But did you know there are actually different kinds of time travel? Join us as we dive into the 8 types of time travel, exploring how they work, their weird effects, and the incredible stories that come from them. So buckle up for a journey through the dimensions of time. Join us as we unravel the mysteries of time travel and discover what's truly possible. Fixed timeline theory, the unchangeable path. This theory is pretty straightforward. Basically, no matter what you try to change in the past, the future stays the same. You can go back and mess around all you want, but the timeline will always course correct to make sure everything ends up how it was meant to. It's kind of like time is set in stone. Imagine this. You go back in time to stop a disaster, but it turns out that in trying to stop it, you actually cause it to happen. Sounds frustrating, right? But that's the essence of this theory. Your actions in the past are already part of the future, and there's no way to escape that. Movies like The Terminator or 12 Monkeys are great examples of this, where the characters think they're stopping something catastrophic, but their actions end up being the very thing that makes it happen. The real mind-bender here is the idea that maybe everything is already written. Every choice, every action, it's all set in motion and we're just playing out the script. Is free will just an illusion? Are we all just along for the ride even though we feel like we're making choices? This fixed timeline concept raises all kinds of philosophical questions. If you can't change anything, does anything you do even matter? For some, that's a comforting thought. Everything is meant to be. But for others, it's unsettling, especially if you like the idea of having control over your destiny. To sum it up, the fixed timeline theory tells us that no matter what we do in the past, time will always find a way to make sure the future stays on track. It's kind of like a cosmic safeguard that keeps everything in line, whether we like it or not. Dynamic timeline theory, changing the future. This theory says that the past isn't set in stone, and if you go back and change something, the future does change. In this version of time travel, you've got the power to rewrite history, and that can have some pretty big consequences. A classic example of this type of time travel is Back to the Future. Remember when Marty McFly accidentally changes things in the past and his whole future is altered? That's dynamic time travel in action. You can tweak events and those changes ripple forward, affecting everything that comes after. It's exciting because it suggests you're not just an observer, you've got the power to make a difference. But here's where things get tricky. You've probably heard of the butterfly effect, right? It's the idea that even the tiniest change can have massive consequences. Step on a bug in the past, and maybe that small act changes the course of history, leading to a totally different present. It sounds far-fetched, but in the world of dynamic time travel, it's a real possibility. You never know how those ripples will play out. This type of time travel is all about responsibility. If you've got the power to change the past, how do you know what changes are the right ones? What if you make things worse? That's the big question here. Just because you can change things doesn't always mean you should. At its core, the dynamic timeline theory taps into our desire to fix mistakes and shape the future for the better. It's the ultimate what-if scenario, where every action you take could have far-reaching consequences. But with great power comes great responsibility, right? Multiverse theory, infinite possibilities. Multiverse theory opens up the possibilities. According to this theory, every time you make a change in the past, you're not altering your original timeline. Instead, you're creating an entirely new one. It's like taking a fork in the road and both paths exist simultaneously but in different universes. So, in this theory, there's not just one timeline. There are infinite timelines with every possible version of reality playing out somewhere. You might go back and change something in the past, but all that does is create a new branch of reality. Your original timeline stays untouched. Imagine stepping into a world where major historical events played out differently. Maybe dinosaurs never went extinct or humans never invented the internet. Crazy, right? This concept is used in a lot of popular media. One example is in Avengers Endgame, where the heroes travel back in time, but instead of changing their timeline, they create alternate ones. In this kind of time travel, every choice creates a new version of reality. The cool part is, every possibility exists, which means somewhere out there, there's a universe where you made a completely different decision than you did in this one. But this also makes you think, if there's an infinite number of realities, does anything matter? If there's a version of reality where every possible outcome plays out, does your particular timeline even matter? It's a wild thought, and it forces you to think about your place in the universe. Overall, the multiverse theory doesn't just limit time travel to fixing the past. It's about exploring whole new worlds, each one different from the last. And the possibilities, well, they're endless. Time loop, the endless cycle. This type of time travel traps you in a cycle where you live the same events over and over again. There's no jumping to the future or past. You're stuck in a loop, reliving the same moments until something or you changes enough to break out of it. A lot of you might be familiar with this from the movie Groundhog Day. The main character is stuck living the same day on repeat, over and over again, until he figures out how to live it differently and escape the loop. Another great example is Edge of Tomorrow, where a soldier keeps reliving the same battle until he can find a way to win. What's interesting about time loops is that they offer a chance for personal growth. You're given infinite chances to get it right, to perfect your actions and decisions. At first, it's frustrating, but eventually it becomes an opportunity. The loop almost forces you to evolve, to become the best version of yourself. But here's the big question. If you're stuck in a time loop, do your choices even matter? If everything resets at the end of the loop, does it matter what you do? This kind of time travel makes you think about the value of your actions and whether or not they have lasting consequences. In the end, a time loop can be both a curse and a blessing. It's a trap, but it's also a chance to learn and grow. And if you can break free, maybe you'll come out of it a better person, or maybe, just maybe, you'll be stuck forever. Quantum leap consciousness time travel. This theory is a bit different. Quantum leap time travel, where it's not your body that travels through time, but your consciousness. You don't physically jump through time, but your mind does, taking over someone else's body in a different era or moment in time. One of the most famous examples of this is the TV show Quantum Leap. The main character, Dr. Sam Beckett, leaps through time and takes over the bodies of people in different periods, trying to fix what went wrong. It's like he's jumping into someone else's life and playing out their role. But he keeps his memories and knowledge. This type of time travel is fascinating because it's not just about jumping through time, it's about experiencing life from someone else's perspective. You're forced to adapt quickly to a new body, a new life, and a whole new set of circumstances. And you have to figure out how to fix things before moving on to the next leap. But that raises some big ethical questions. If you're controlling someone else's body and making decisions for them, is that fair? Do you have the right to interfere in their life, even if you think you're helping? It's a tricky moral situation, and one that makes this form of time travel particularly unique. In quantum leap time travel, the focus isn't so much on the science, but on the emotional and moral growth of the traveler. It's a journey of self-discovery, as much as it is a journey through time. Alternate reality travel, diverging from the main timeline. This theory is pretty wild because it's not just about jumping through time, it's about jumping into a completely different version of reality. In alternate, you visit a version of the world where key decisions play out differently, leading to an entirely different timeline. This isn't about creating new timelines like in the multiverse theory, it's about seeing how one change in the past led to a radically different present. Think of shows like Fringe, where characters explore parallel realities to stop major disasters. Or imagine visiting a world where major historical events like the American Revolution or the moon landing never happened. In this type of travel, you're not just an observer of a different timeline, you're part of it. You might even encounter alternate versions of yourself, which raises some big questions about identity. If another version of you exists, what does that say about your current self? Are you just one of many possibilities? What's also interesting is that alternate reality, the fragility of history. A single decision or event can lead to a different outcome, making you wonder how much of our world is shaped by chance. In conclusion, alternate reality travel lets us explore the what-ifs of history. It's about more than just time. It's about seeing how different choices lead to different futures, and it forces us to confront some deep questions about identity and fate. Causal loop, the paradox of self-creation. The causal loop, also known as the bootstrap paradox, is where things get confusing. In this kind of time travel, events are caught in a loop where the cause and the effect are the same. It's like a never-ending cycle with no clear beginning or end, and the traveler might end up being the cause of the very thing they're trying to prevent. One of the best examples of this is the movie Predestination, where the main character discovers they're responsible for several key events in their own life. The same kind of loop appears in Harry Potter when Harry goes back in time with the time turner and ends up saving himself. In both cases, the actions they take in the future were always a part of the past. Then there's the bootstrap paradox, which is when something exists without an origin. Imagine going back in time and giving Shakespeare a copy of his works, and he publishes them. But where did the works originally come from? They exist in a loop, without a clear point of creation. This type of time travel raises big questions about free will and fate. If you're part of a loop, are you making choices, or are you just playing out a script that's already been written? It's a paradox that challenges the way we think about cause and effect. In the end, the causal loop is one of the most mind-bending forms of time travel, where time folds in on itself, and everything you do is both the cause and the result of the same event. It's enough to make your head spin. Time dilation, traveling through time by slowing it down. This theory is grounded in real-world science thanks to Einstein's theory of relativity. It happens when someone or something moves at speeds close to the speed of light, causing time to slow down for them compared to everyone else. So, while the person traveling at near light speed experiences time more slowly, the rest of the world keeps moving at a normal pace. In theory, this could allow you to travel into the future. You wouldn't jump ahead instantly, but by the time you return to normal speed, everyone else will have aged much faster. It's like fast-forwarding through time. A great example of time dilation is in the movie Interstellar. Remember how on the planet near the black hole, time moved much slower? For every hour spent on the planet, years passed back on Earth. That's time dilation in action. It shows how time can warp in extreme environments, especially where gravity or speed plays a big role. This isn't just science fiction either. It's been observed in real-life experiments. Astronauts on the International Space Station experience time slightly more slowly than people on Earth because they're moving so fast. While the difference is tiny, it proves that time dilation is real. Time dilation is fascinating because it offers a way to travel through time, though only forward. You can't go back, and once you move ahead, there's no reversing it. Still, it's one of the few forms of time travel that's possible according to the laws of physics. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.
Have you ever wondered what makes our solar system so extraordinary? From moons that spew ice volcanoes to storms that have raged for centuries, the solar system is full of astonishing phenomena that defy imagination. Did you know that some planets have magnetic fields so strong they could disrupt your compass from millions of miles away? Join us as we dive into the top 7 most unique features of our solar system, unveiling the wonders that make our celestial neighborhood one of a kind. The Great Red Spot on Jupiter. Let's talk about one of the most jaw-dropping wonders in the solar system, Jupiter's Great Red Spot. This colossal storm is so massive it could swallow Earth whole, spinning for centuries like a never-ending cosmic hurricane. More than just a storm, it's an iconic feature of Jupiter, a reddish-orange vortex that has raged for at least 400 years. With winds tearing through it at up to 430 miles per hour, it's more ferocious than the strongest hurricanes on Earth. What powers this tempest? Unlike Earth's storms, which feed on warm ocean water, the Great Red Spot draws energy from Jupiter's internal heat. This heat, generated by the planet's immense size and gravitational compression, fuels the storm like an unstoppable engine. Fascinatingly, the Great Red Spot has been shrinking over the past century. Once over 25,000 miles wide in the late 1800s, it's now about 10,000 miles across, still large enough to fit Earth but steadily diminishing. No one knows why it's shrinking, but it raises a compelling question. Could this ancient storm disappear in our lifetime? Beyond its visual grandeur, the Great Red Spot is a scientific treasure. Studying it reveals insights into gas giant atmospheres and the dynamics of extreme weather systems. It also helps scientists understand similar phenomena on distant exoplanets. Jupiter's Great Red Spot is more than a storm. It's a blend of beauty, power, and science, swirling together in one mesmerizing spectacle. Saturn's rings, a cosmic masterpiece. Saturn's rings are undoubtedly one of the most breathtaking sights in our solar system. Picture this: a planet wrapped in shimmering bands of icy particles stretching across hundreds of thousands of miles. These iconic rings make Saturn the showstopper of the night sky, often called the jewel of the solar system. What's fascinating is that these rings aren't solid. They're made up of countless chunks of ice and rock, ranging from tiny grains to massive boulders, all orbiting Saturn like cosmic dancers. What's even more astonishing is how thin these rings are. Though they span up to 175,000 miles across, they're only about 30 feet thick on average, like stretching a sheet of paper over a football field. Scientists believe the rings formed from debris of shattered moons, comets, or asteroids caught in Saturn's immense gravity. It's a stunning example of the universe turning chaos into beauty. The brightness of Saturn's rings comes from their composition, mostly water ice, which reflects sunlight brilliantly. The rings are divided into distinct sections such as the A, B, and C rings, with gaps like the Cassini division creating a mesmerizing, intricate pattern. This combination of shimmering ice and dramatic gaps makes Saturn's rings look like the universe's most elegant jewelry. Here's the bittersweet truth: Saturn's rings won't last forever. Over time, gravity pulls the particles toward the planet in a process called ring rain. While the rings are expected to disappear in tens of millions of years, we're fortunate to witness their beauty now. Saturn's rings aren't just a cosmic masterpiece, they're a fleeting one, reminding us of the ever-changing nature of the universe. They are a spectacular blend of science and art, offering a glimpse into the creativity of the cosmos. Enceladus, the moon that sprays water into space. Enceladus might seem unassuming at first glance, but this tiny moon of Saturn is one of the most remarkable places in our solar system. Just 310 miles wide, it's covered in bright white ice that reflects nearly all the sunlight it receives, making it one of the most reflective objects in space. But what truly sets Enceladus apart is its spectacular geysers, which shoot massive plumes of water vapor, ice, and organic molecules into space. These geysers erupt from cracks near the moon's south pole, known as tiger stripes. What's even more fascinating is that scientists believe the water comes from a vast subsurface ocean hidden beneath its icy crust. Despite its cold, distant location, Enceladus's ocean remains liquid due to tidal friction, heat generated by Saturn's gravitational pull and interactions with nearby moons. This makes Enceladus one of the few places in the solar system where liquid water might exist, raising the tantalizing possibility of life. The material ejected from the geysers doesn't just fall back to the moon, it also contributes to Saturn's faint E-ring. NASA's Cassini spacecraft even flew through these plumes, discovering organic molecules, the building blocks of life. This incredible finding has made Enceladus a key focus for astrobiology, as its hidden ocean could potentially harbor microbial life. Future missions are already being planned to explore Enceladus further. Scientists hope to land probes on its surface or sample its plumes directly to search for signs of life. Enceladus isn't just another icy moon, it's a beacon of possibility in our quest to find alien life. This tiny, icy world reminds us how much mystery and wonder still await in the vastness of space. Wouldn't you love to explore it? The Sun's mysterious corona. The Sun isn't just a fiery ball of gas. It's a cosmic powerhouse full of mysteries, and one of its most fascinating features is the corona. The corona is the Sun's outermost atmospheric layer, and it's not just hot, it's astonishingly hot. While the Sun's surface is around 10,000 degrees Fahrenheit, the corona reaches a staggering 1 to 3 million degrees Fahrenheit. That's millions of degrees hotter than the surface, a phenomenon scientists are still trying to understand. One of the most mesmerizing views of the corona happens during a total solar eclipse. When the moon blocks out the sun, the faint glowing halo of the corona appears, its flowing plasma creating an almost magical spectacle. But don't be fooled by its beauty. The corona is an incredibly dynamic and volatile region. It's the birthplace of solar winds, streams of charged particles that travel at up to 500 miles per second, creating auroras on Earth but also threatening satellites and power grids during intense solar storms. The mystery of why the corona is so much hotter than the sun's surface, known as the coronal heating problem, has puzzled scientists for decades. Some theories suggest bursts of energy called nanoflares, created by the sun's magnetic fields, might heat the corona. Others propose that energy waves traveling through the sun's magnetic field deposit heat into the corona. Missions like NASA's Parker Solar Probe are venturing closer than ever to solve this cosmic puzzle. Beyond its scientific intrigue, the corona plays a critical role in shaping space weather across the solar system. Solar flares and massive plasma eruptions, known as coronal mass ejections, originate in this mysterious layer, sending shock waves through space. Understanding the corona isn't just about solving solar mysteries, it's essential for protecting Earth's technology and future space missions. So the next time you gaze at the sun, remember it's not just a star. It's a celestial enigma with a crown of fire that both inspires and challenges our understanding of the universe. Neptune's supersonic winds. When it comes to extreme weather, Neptune takes the crown as the wildest planet in our solar system. Imagine winds so powerful they reach supersonic speeds of over 1,200 miles per hour, faster than the speed of sound. These are some of the most intense winds ever observed, making Neptune a chaotic weather powerhouse. The surprising part? Neptune is incredibly far from the sun, and its atmosphere should be freezing and calm. Instead, it's a stormy, dynamic world. Neptune's atmosphere, made mostly of hydrogen, helium, and methane, gets its beautiful deep blue color from the methane. But beneath that serene exterior lies an incredibly turbulent environment. The planet's winds are driven by a combination of internal heat and rapid rotation. Remarkably, Neptune generates more heat from its core than it receives from the sun. This heat rises and interacts with the atmosphere, creating conditions for the planet's astonishingly fast winds. Combine this with Neptune's quick 16-hour rotation, and you have a recipe for atmospheric chaos. One of Neptune's most famous weather phenomena is the Great Dark Spot, discovered by Voyager 2. This massive storm, comparable in size to Earth, had winds that reached extraordinary speeds. Although it disappeared after a few years, other storms have since emerged, keeping Neptune's atmosphere as unpredictable as ever. Scientists are still studying how these storms form and why Neptune's winds are so much faster than those on other planets. Neptune's violent winds aren't just a weather marvel, they're a scientific mystery. Understanding them can provide valuable insights into the atmospheres of other gas giants and even distant exoplanets. So the next time you see a picture of Neptune's calm, stunning blue, remember it's hiding some of the fastest and most chaotic winds in the solar system. Beneath its tranquil appearance lies a dynamic world of relentless storms and incredible speed. The Kuiper Belt's hidden worlds. Let's journey to the edge of the solar system, where the mysterious Kuiper Belt lies, a vast, icy expanse that's like the solar system's secret attic. This ring of icy debris, located beyond Neptune, stretches billions of miles and holds remnants from the solar system's formation. It's a cosmic time capsule filled with ancient hidden worlds waiting to be explored. While Pluto is the most famous resident, it's just one of thousands of fascinating objects in the Kuiper Belt. The Kuiper Belt is home to dwarf planets, comets, and countless icy bodies known as Kuiper Belt objects, or KBOs. Made of frozen gases, water, and rock, these objects are around 4.5 billion years old. Among them are dwarf planets like Pluto, Eris, Haumea, and Makemake, each with unique traits. Haumea, for instance, has a bizarre egg-like shape and rapid rotation. These icy bodies are like ancient relics, offering a glimpse into the solar system's early days. One of the most fascinating aspects of the Kuiper Belt is its role as a source of comets. When KBOs are knocked out of their orbits, they can travel toward the inner solar system, becoming comets with bright tails as they near the sun. These cosmic travelers offer clues about the raw materials that help build the planets, like postcards from the solar system's past. Despite its significance, the Kuiper Belt remains largely unexplored. NASA's New Horizons mission gave us the first close-up view of Pluto, and has since studied other KBOs like Arrokoth, a snowman-shaped object that has deepened our understanding of these distant worlds. This icy region challenges what we know about planetary formation and the outer solar system's dynamics. The Kuiper Belt isn't just the solar system's outer edge, it's a gateway to uncovering the history of our cosmic neighborhood and understanding our place in the universe. Who knows what secrets this icy frontier still holds? It's a reminder of how much there is left to discover beyond the familiar planets. The solar system's magnetic bubble. Let's dive into one of the most fascinating features of our solar system, the heliosphere. Picture a giant bubble stretching billions of miles, wrapping around all the planets, asteroids, and comets, shielding us from the harshness of interstellar space. This massive magnetic bubble, created by the sun, acts as the solar system's personal shield, constantly shaped by solar winds and cosmic forces. The heliosphere begins at the sun, where the solar wind, streams of charged particles traveling at millions of miles per hour, radiates outward, carrying the sun's magnetic field. As these particles travel, they form a boundary marking the edge of the sun's influence, known as the heliopause. Beyond this boundary lies interstellar space, filled with cosmic rays and interstellar winds. The heliosphere blocks much of this harmful radiation, creating conditions that make life on Earth possible. What's remarkable is how alive the heliosphere seems. The sun's 11-year activity cycle causes the heliosphere to expand during high solar wind output and contract during quieter periods, like a pulsating balloon. NASA's Voyager 1 and Voyager 2 spacecraft crossed the heliopause, providing groundbreaking data about this boundary and revealing what lies beyond. The heliosphere's significance extends far beyond shielding us from cosmic rays. It plays a key role in understanding how our solar system interacts with the galaxy and could impact space travel or even extraterrestrial life. The heliosphere isn't just a shield, it's a dynamic, evolving force connecting us to the universe at large and shaping the way we understand our place in space. And that's a wrap on the solar system's most unique features. From the violent winds of Neptune to the icy plumes of Enceladus, our cosmic neighborhood never ceases to amaze. If you enjoyed this journey through space, don't forget to like, share, and subscribe to InnoVision Tech. Hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us. Imagine waking up 100 years in the future, cities floating in the sky, AI running the world, and humanity exploring distant galaxies. Sounds like science fiction, right? But what if time travel wasn't just a fantasy? What if the secrets to bending time were hidden in physics, waiting to be unlocked? From Einstein's theories to real-world experiments, scientists have uncovered mind-blowing clues that suggest time travel might actually be possible. But how close are we? Is there a way to break the rules of time? Buckle up, because today we're diving deep into the future of time travel. Understanding time travel. Ever wished you could hit rewind on life? Or maybe fast forward to the future? Well, guess what? Time travel might not just be science fiction. It's a real possibility, at least in theory. The laws of physics suggest that time isn't as straightforward as we experience it. It bends, stretches, and even slows down under the right conditions. Mind-blowing, right? It all starts with Einstein's theory of relativity. Unlike the ticking clock on your wall, time itself is flexible. It changes depending on how fast you're moving or how strong gravity is around you. This means that time isn't an absolute universal constant. If you were speeding through space at near the speed of light, time for you would slow down compared to someone on Earth. So, in a way, time travel forward is already happening, just on a very tiny scale. But what about traveling back in time? That's where things get tricky. In theory, certain solutions in Einstein's equations, like wormholes or cosmic strings, suggest it could be possible. However, there's a major roadblock: paradoxes. Imagine going back in time and stopping your grandparents from meeting. Would you even exist? This is the infamous grandfather paradox that makes backward time travel incredibly complicated. Scientists continue to explore theories like wormholes, black holes, and quantum mechanics to crack the mystery of time travel. But for now, while the math hints at the possibility, technology is nowhere near making it a reality. The question isn't just, can we travel through time? It's, should we? Forward time travel. Here's something wild. Time travel to the future is already happening. Not in a sci-fi movie way, but in real, measurable physics. We're all time travelers, moving 1 second per second. But did you know that with enough speed you could skip years, even centuries, into the future? Thanks to Einstein's special relativity, we know that time slows down for objects moving at extreme speeds. This phenomenon, called time dilation, has been proven with high-speed jets and atomic clocks. Put simply, the faster you move, the slower time ticks for you compared to someone standing still. So, if you were traveling in a spaceship near the speed of light, years could pass for people on Earth, while you'd only experience a few days or weeks. And it doesn't stop there. Gravity also affects time. The stronger the gravitational field, the slower time moves. Astronaut Scott Kelly spent 340 days in space, and when he returned, he was slightly younger than his twin brother, who stayed on Earth. Why? Because Earth's gravity slows time down for him compared to Scott, who was in orbit. This means forward time travel isn't just a theory, it's proven science. The catch? To truly leap into the distant future, we'd need to travel at near light speeds, something far beyond our current technology. But who knows, maybe one day space travelers will return home to find centuries have passed, while they've only aged a few years. So, while backward time travel is full of paradoxes, forward time travel, it's not a matter of if, it's a matter of when. Backward time travel. Alright, let's get to the real mind-bending stuff. Traveling back in time. Imagine stepping into a machine, dialing in a date, and suddenly finding yourself in ancient Egypt, or warning the Titanic before it sinks. Sounds incredible, right? But here's the catch. Backward time travel is way more complicated than moving forward. Physics doesn't outright forbid traveling to the past, but it throws a bunch of challenges our way. The biggest issue? Paradoxes. Ever heard of the grandfather paradox? If you went back and stopped your grandparents from meeting, you'd never be born. But then who traveled back in time in the first place? It's a loop that breaks reality. Some scientists argue that time might fix itself in weird ways, preventing changes that would create contradictions. Others suggest multiple timelines, meaning if you change the past, you'd just create a new alternate universe instead of rewriting your own. So how could we actually go back in time? One idea involves closed time-like curves, predicted in Einstein's equations. These would allow you to loop back in time, but so far we don't know if they could exist in the real world. Another theory, cosmic strings, massive, ultra-dense objects stretching across the universe that might warp spacetime enough to allow for time loops. But there's no evidence these strings exist. Then there's the biggest question of all. Even if we figure out how to travel backward in time, should we? If history could be rewritten, would we even recognize our present? The past might be set in stone for a reason, or maybe we just haven't found the right key yet. Wormholes. If you want to time travel like in the movies, you need something better than a DeLorean. Enter wormholes, hypothetical tunnels through space and time. If they exist, they could connect two distant points in the universe, allowing you to step into one end and instantly pop out in the past or future. Sounds too good to be true? Well, it might be. A wormhole, also called an Einstein-Rosen bridge, is basically a shortcut through space-time. Picture space as a sheet of paper. If you fold it and poke a hole through, you create a direct path between 2 points. In theory, if you move one end at near light speed or place it near a supermassive gravitational force, time inside the wormhole could pass differently than outside. This could create a natural time machine, but here's the problem. Keeping a wormhole open is nearly impossible. The moment anything tries to pass through, it collapses faster than you can say, flux capacitor. To stabilize one, you'd need something exotic, literally. Scientists believe a form of negative energy, which we haven't discovered yet, could hold it open. Without that, a wormhole would be more of a cosmic death trap than a time portal. And let's not forget the paradoxes. If wormholes allowed backward time travel, we'd run into the same problems as before. Could you travel back and erase your own existence? Would the universe even allow that? Some scientists think time travel paradoxes might fix themselves through quantum mechanics, meaning any action you take in the past just creates a new timeline rather than affecting your own. So, are wormholes the answer? Maybe. The math works, but the technology is pure science fiction, for now. The real question is, if we ever did find a way to open one, would we be brave enough to step through? Time travel future prospects. So, we've talked about theories, paradoxes, and even wormholes. But here's the real question. How close are we to making time travel a reality? Well, let's just say, don't pack your time machine suitcase just yet. The truth is, while the math behind time travel works, our technology is nowhere near capable of making it happen. First, let's talk about speed. We know that traveling at near light speed slows down time for the traveler. But here's the problem. We don't have anything that can move that fast. Our fastest spacecraft, the Parker Solar Probe, moves at 430,000 miles per hour, but even that is just 0.06% the speed of light. To time travel significantly into the future, we'd need to reach at least 90% of light speed, and right now that's impossible. Then there's the issue of energy. Wormholes? They need negative energy to stay open, and we haven't figured out how to create or harness that yet. Even if we did, stabilizing a wormhole would require insane amounts of energy, far beyond anything we can generate. Think about it. We're still struggling to make nuclear fusion practical, and that's child's play compared to what time travel would demand. And let's not forget gravity. Black holes might hold the key to time manipulation, but good luck getting close to one without being spaghettified. Scientists theorize that extreme gravitational fields slow down time, but harnessing that effect in a controlled way? That's not happening anytime soon. So, is time travel impossible? Not necessarily. Science is always evolving. A few centuries ago, the idea of flying across the world in hours was unthinkable. Now we take it for granted. If we crack the mysteries of quantum mechanics, advanced propulsion, or even exotic matter, who knows what doors might open? One thing's for sure, the future of time travel is uncertain. But hey, maybe some future traveler is watching this right now, laughing at how clueless we were. If that's the case, drop us a hint, will ya? So, is time travel just a dream, or are we closer than we think? While science has given us glimpses of what's possible, the technology is still far behind, but who knows? Maybe in the future someone watching this video will be the one to crack the mystery of time travel. If you enjoyed this deep dive, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing tech and science content. Until next time, stay curious, stay futuristic, and keep exploring the unknown.